Often we're told that data to computers are just ones and zeros, and what this means is that computers don't actually understand or know what the data is that they're dealing with and what they're referring to. Like, say you send your email to your friend. Technically, your computer doesn't really understand what that data is, and even when that data is stored in its memory, and as that computer is transmitting that information to another computer, and then that computer receives that email, that information is transmitted as ones and zeros. And so this is what is meant by your computer stores data as ones and zeros. What your computer does with that data is that it takes those ones and zeros and then it displays them in such a format to a human in the form of words, characters, phrases, sentences. And so it is actually the human that assigns value and meaning to that data. But the computer itself doesn't know what that data is. And so it's kind of like if you can imagine you're in a room with two people who are speaking in a foreign language and you're communicating or you're sharing what one person is saying to the other person. You don't know what those people are saying, but it's only those two people who are communicating that know what they're saying. So you can take what they're saying and share what person A is saying and share it to person B. And you don't know what the words are saying, but person A and person B, they know what those words are saying. And so that's kind of like what's happening with computers. We're like those person A and B who are speaking in human language, and then computers are just relaying that information from one person to another. So how exactly do computers store data as ones and zeros and then transmit and share that information or communicate that information to other computers? And what does this have to do with bits and bytes? So in this video, I'm going to be talking about what bits are, what bytes are, and then I'm going to show you an example of how data is actually stored in a computer, in a program. So my name's Henrik and I'm here to help you learn the foundations of software development. So let's get started. But before we begin, I'd like to mention that I do have a free workshop for you. It's called my Capstone Project Workshop. And in that workshop, I go over 3 secrets to coding your own Capstone project in just 3 months. Now, why did I create this workshop? The most common goal that I get from people who apply to my one-on-one programming mentorship program is to, quote, be more proficient at creating projects. You and I both know that learning how to code is more than just memorizing code syntax. It's about applying your coding skills to real-world projects that make you feel confident and capable. So if this sounds like you can download this workshop in the link in the description. And if you download it and watch it and pay attention to what it says, then you'll definitely build a good foundation to your software development journey. Alright, so first let's start with bits. What are bits? So a bit is the smallest unit of data in a computer, and it can only hold one of 2 possible values, 0 or 1. And so every data, even in this file here, all of this data here that's stored in this readme.txt file, this is actually stored as a sequence of ones and zeros. And even this video, even my voice, as you're hearing it, it's stored as ones and zeros. But then your devices are able to decode those ones and zeros and display it or make it audible in the form of my voice that you're hearing right now. And so computers, they store all this data as a sequence of bits. And then that's because transistors inside a computer can only have 2 states. So they can have an on state or an off state. So on corresponds to 1 and off corresponds to 0. So we have these devices, these physical devices in our computers called transistors, and they have these 2 states. And this is why we decide to store our data as a sequence of ones and zeros. And so if you can just imagine 8 light switches in a row, say the first 3 light switches are on, and then the next 2 are off, and then the next one's on, the next one's off, and the next one is on, then we have this sequence of bits. So we have 1, 1, 1, which corresponds to the first 3 are on, and then the next 2 are off, and then the next one is on, the next one's off, and then the next one is on. And so just by having these light switches are actually carrying some data. So they have some data, and this is the data that it's storing, so to speak. So we have information here being stored in our computer in the form of ones and zeros. Now, if you have 8 light switches in a row, or if you have 8 bits of data, that actually leads into our next concept, which is bytes. So what are bytes? A byte is just another unit of data that consists of 8 bits. And so this is actually a byte already. So you already know what a byte is. It's just a sequence of 8 bits. And what does this have to do with hexadecimal. Hexadecimal is a number system where each digit represents 16 possible values. And this is important because this is how we like to express our bytes. This is how we like to display this byte of information. We like to convert this into a hexadecimal format. And so let's talk about hexadecimal a little bit, and then you'll see where I'm going with this. So in hexadecimal is a number system where each digit represents 16 possible values, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, E, F. And so these are 16 possible values, and A corresponds to the number 10, or the value of 10, B corresponds to 11, C corresponds to 12, D corresponds to 13, E corresponds to 14, and F corresponds to 15. And this starts getting into talking about base systems. So naturally, we have a base 10 system where we count in groups of 10. And so we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we do 10. So we had two digits to express. We have this next digit, 1, 0, to say that we're going into the next group. And then in hex, what we do is we count up to 16 values, but then it's only after F that we have 1, 0. So if we're counting in hex, in the hexadecimal format, we're counting up all the way up to F, and then it's only up until after F that we will say 10. And so this is kind of hard to understand in the beginning, but it's pretty easy. Just count and keep going until you hit the 16 numbers. And A is considered a number now, B is considered a number, but these are just one-digit numbers. So I talked about base 10. Base 10 is when we count we count from 0 to 9, and then we go 10. We do the double digits after 9. But then there's also, I didn't talk about binary. So binary is when we count in groups of 2. And so the only two values in binary are 0 and 1. And that sounds familiar, right? This is corresponding to bits that we talked about here. So we only have two states here. So if we were to count in binary, it would be like this. It would be 0, 1, and then we've hit the group. We've already hit two numbers here. So now we can go into double digits, and we do a 10, and then 11, and then, okay, so now after 11, can you guess what the next digit is going to be that we're going to count? So maybe you're thinking, oh yeah, that's going to be 20, right? Well, you have to remember we only have zeros and ones in this number system. So it's actually not 20, it's going to be 100. And then we count some more. We go 101, and then we count again. Now we had that group of 2, so now we go to 10, 110, and then we go 111, and then can you guess what comes after this? Is it 211? No, because we only have zeros and ones in this format, so we have 100. So this is how we count in binary, but these numbers actually correspond to, if we want to correspond to 10, so just to give you some more understanding, this is still 0, this is still 1, this corresponds to 2, this one corresponds to 3, this corresponds to 4, 5. So I'm still counting in base 10. So 6, this corresponds to 7, and this corresponds to 8. So in base 10, these numbers would be 0, 1, 2, 3, 4, 5, 6, 7, 8. So in other words, if you want to say 8 in binary, you would say this number. This number is 8 in binary. Now, if you want to go into hex, hex is going to be the same thing because these numbers are valid numbers in the hex, in the hexadecimal number system. All right, so now I've talked about base 16. Why are we talking about it, and why do we use it? So base 16, as I alluded to earlier, is actually the format that we like to use to express bytes. So when we talk about bytes, we usually like to express them as a hexadecimal number. We don't like to express our bytes in this format because this is too long, and then there's too many ones and zeros. It's hard to keep track. But if you can express it in bytes, it's easier to look at and it's more meaningful. and you'll start to see where I'm coming from when I show you how we convert binary to hex. And this is another reason why we use hex, because it's easy to convert this into the hexadecimal format. We have this binary to hex conversion table, and when you've been programming for a while, you'll start to be able to do this conversion. You'll start to memorize this conversion table as if it was like your multiplication table. So we would know automatically 0 corresponds to 0, 1, 1, 10 corresponds to 2, 11 corresponds to 3, etc., etc., etc. And so you start to memorize this table. And so when you see this byte here, if we convert it, this one here corresponds to E, and then this corresponds to 5. And then so if you look at this binary or this byte here, it's actually expressed as E5. So when you see people talk about a byte, they would express it as like this. And we have the X here to designate that this is a hexadecimal number. And the reason why we do the 0x there is because sometimes you can have 0x 40 or 35, and then this is different than the regular number 35, because 35 in hex is a much larger number than this 35 in decimal. And likewise, we have another way of formatting our binary numbers. We would do 0b and then 1110 and then 0101. So this is how we would express binary numbers to differentiate it from a regular decimal number that's this size. So that's a brief introduction on bits and bytes. I want to give you a challenge here. Can you comment down below what this sequence is in hex format? So we have 1011. You can use this table here to convert it. So comment down below what this sequence is in hex. Okay, I shared a lot of theoretical information. Now let's see it in our actual programs. So I have a program here called bitsbytes.c. So we have a number here, 42, and then we have a character here, A. And I'm just going to show you how your computer, or how my computer, is storing this information in memory. So we have a printf here. We're just going to display the number, and then we're going to display where that number is located, the address. And then we're going to display the bytes of the number in memory. And so here we have an int. A number is an int, and that's generally speaking, int is 4 bytes. So after this printf, we're going to say these are the bytes of the number in memory, and then we're going to have a pointer that's going to point to the address of the number, and then we're going to go through each byte of that number. And this is unsigned char because unsigned char is 1 byte. So unsigned char is 1 byte. And when you have this pointer here, we're pointing at the first byte of this number 42. So we're going to show you what 42 looks like as it is expressed in, or as it is stored in 4 bytes. And then we have a for loop here. We have I here, and then I is going to go for size of int. Size of int is going to return 4. So we're going to have 4 prints here for each byte of the int. And then we're going to use this %02x to display this as a hexadecimal number. And then we're going to iterate through byte pointer. So when I is equal to 0, this byte pointer is going to point to the first byte in number. And then when it goes through another time, I is going to be 1. So it's going to point to the next byte in number, and so on and so forth. And then we're going to print these end-of-line characters. So let's just run this right now and see what it looks like. I'm going to comment this out first. Okay, so here's the number 42. It's stored at this address here. And so you see the X there. This X is saying that this number is a hexadecimal number. So that's why we see F, D, F, and C, because like I mentioned here, these are actually corresponding to particular digits in the hexadecimal format. So we have FD, FC. So that's FDFC. So those are valid digits in the hexadecimal format. And then when we're displaying the bytes of the number in memory, we have 2A 000000. And why does this correspond to 42? So the least significant byte of this integer is stored in as the first byte, and this is called little endian. And this can get into another conversation about little endian versus big endian, but don't worry about that for now. Just know that this is the number that corresponds to 42. All right, so let's just convert 2a into decimal. So we have 2a here. That means we have two groups of 16. So we have 2 times 16, and then we have a, which is just 10 in decimal, right? Because we have 10. So a here corresponds to 10. So if we do the math here, two groups of 16, that's going to be 32 plus 10, which is 42. So now maybe you might be asking, why do we need these zeros here if we're just going to store 42 as 2a? Why do we need these? So if we want to have a number that's higher than ff, so ff is the highest number that you can store in this byte here. So ff in binary is just 1111 and then 1111. So this is the highest number that you can store in a byte. So if you want a number that's higher than ff in decimal is 255. So if I have this number here, if I do 255, you'll start to see, so now 255 is stored as ff here. Now if we do 256, and then now you see we're using this second byte now. So this is 256 stored in memory in this memory location as 0001 0000, but because it's little endian, it's going to be 000001 and 00. It's just 1000, and if you convert this into decimal, this is 256. All right, so enough of the number, let's go into the character. So how is a stored in memory? So let's comment out this part. Okay, so we have a printf here. This character C letter is going to be a character stored at this address, and then the byte of that character in memory. So like I mentioned earlier, unsigned char is only 1 byte. So we only have to have one printf. We don't have to have this for loop to go through all the bytes because it's only 1 byte. So we're going to display this character in memory. So what does a look like in memory? All right, so there's character a, the character stored in this address, and then the byte of the character in memory is 41. And why does a in memory become 41? So we have this thing called ASCII table, and like I mentioned at the beginning of the video, computers can only understand numbers. So an ASCII code is a number, a numerical representation of a character such as a or @ symbol or an action of some sort. And so we just need to find our character a. So there's our character a. Yeah, here's our character a. And then if you look at the hexadecimal representation of a, it becomes 41. And so that's why a is stored as 41 in our program. Now we can try another character. Let's try doing h. Let's run that. Okay, h is stored as 48. And so let's go back to our ASCII table. Okay, there you go. H is 48. And that's 48. So that's why h is stored as 48. And so like I mentioned earlier, if you're sending an email to your friend, say, hello friend. This hello friend, as it's stored in your computer, is actually going to be stored as that phrase is going to be stored as hexadecimal numbers. Like 48 is going to be the h, and then we have to find lowercase e. Okay, so here's lowercase e. That's going to be 65. And then L is 66C. So you can get the picture here. Hello friend is actually not stored as hello friend in your computer. It's actually stored as these numbers. And then these numbers are actually just the hexadecimal representation of binary. And I know if this is your first time learning about it, especially about the base systems, it can be kind of confusing. So just feel free to let me know in the comment section if there's something that you're not clear about. And so this is how we're actually storing data in our computer. So you just have ones and zeros corresponding to on and off, and then a sequence of 8 ones and zeros is a byte. And so all of our information is stored like this in our computers. Like I mentioned earlier, I have a free workshop for you, my Capstone project workshop. And in that workshop, I go over 3 secrets to coding your own Capstone project in just 3 months. So if you want to become more proficient at creating your own projects, you want to move on from these tutorials and create your own projects, then be sure to check the link in the description and watch my coding workshop today. Alright, that's it for this week's video. I hope it really helped you out and helped you understand what bits and bytes are and how they are used by computers to store data and information, and as well as transmit that information to another computer. So I hope it really helped you out, and if it did help you out, please like, share, and subscribe to the channel. And if you have any other questions, feel free to let me know in the comment section, and I'll be sure to answer you there, and I'll see you in the next one. Peace.